get back to the activation energy aspect of that, because to me, like, that is one of the things that I've always used in, one of the big technology aspects of green sensation, which we'll talk about, is really, again, more efficiently being able to produce your own hormones, your own oxins, things like that, which we'll talk specifically about. But in most chemical reactions, an energy barrier actually exists that must be overcome for the reaction to occur. Again, that's where enzymes come in. This barrier prevents complex molecules such as proteins and nucleic acids from spontaneously degrading, and so is necessary for the preservation of life. Pretty important, it sounds like.
We're Jug Dealers, we're the podcast you need in your feed. Teaching the game like you never seen. Jared, Gabe, Rambo, true OGs. Masters of the globe, set your mind free. From Denver, Colorado, where the data's green. We set the data points for the SOPs. Jug Dealers Podcast, yes indeed.
Hey, everybody. Welcome back to the Jug Dealers Podcast, where we discuss all things cannabis and lifestyle related, brought to you by the good people at 5E. And now we have JugDealers.net and JugDealers.shop. So
yes, indeed we do.
There for all your needs, whatever you want. We have product. We've got merch. If you want to ask us some questions, I think you can.
Yeah, there's a comment section on there. And soon we also will have a sample tab. I know that Josh has been working on that. Currently right now, people are requesting samples through the comment box. That'll be a little bit more where like technical questions will go in the future. And then for direct sample requests, we will have a sample tab. If you want to comment,
we're finalizing that right now. We said last week it should be open this week, but there's always we got to get clearance. It's ready, but I got to get someone to tell me.
So many hurdles to jump through. But until then, you can always reach out. We always say to folks, this is our sample call out. If you want to try one or a couple of our products, whatever you see on the website, whatever you see us talking about, whether you're commercial or a home grower, we're about the people. Obviously jug dealing comes from we'll give you a little taste. You're going to like the rest. Today's episode is a really big episode, really fun. We love doing the educational stuff, not only because we love sharing the information, but it's just good to go back and refresh ourselves and kind of, even learn some more stuff, which I constantly find I do, even if I'm reading things I've read 20 times before.
Well, maybe I'm even just like interpreting it differently now too.
I have a better understanding, and all of a sudden something I read before makes a lot more sense.
True.
So this was a fun episode to put together. Jayhawk did a lot of work on this one. This is the episode about enzymes. Today we're going to be discussing, and defining enzymes. What are they? What the hell are they?
What the heck are they? So we're going to talk about that.
Ultimately, a lot of folks talk about the 17 essential elements, but as Jayhawk is so keen to point out, there's so many other things that really make it all happen.
There's a lot going on.
There's a lot going on, and this is stuff that we feel is really important. This is a lot of stuff that we talk about with New Millennium that kind of separates us from a lot of other people, because yes, 17 essential elements work, but
what about everything else?
Everything else? So we're going to give you a little history. We're going to talk about enzymes in plants specifically, because realistically all life needs enzymes, but we're going to talk about plants specifically.
We talk about plants here.
What their importance is.
People.
And then a special little thing about Rubisco. So let's get it kicked off with the enzyme section. Jayhawk.
Yes, sir.
Take it away for us, bro.
Absolutely. So again, let's just kick it off right now. Define really what enzymes are, and kind of feel our way through this a little bit. And then actually here in a little bit, I'm letting Gabe pull up a little excerpt that we're going to pull out of good old teaming.
Good old Jeff's book, microbes. We love Jeff.
Until then. All right. So what are enzymes? Enzymes are proteins that act as biological catalysts by accelerating chemical reactions. The molecules upon which enzymes may act are called substrates, and the enzyme converts the substrates into different molecules known as products. It's sometimes obviously pretty important to define these things so that later on when we're talking substrates and products, you guys know what's going on. You don't think that it's like soil or cocoa or something like that. So I want to define a couple things.
And we bring up a lot that things need to happen in order for the elements to be available for the plant to actually utilize these elements. That's why
it's got to line up.
Well, and that's why there are certain places where you see a lot higher, use of elements, because there's not as there's not as much of that biological life
and really activity going on, so it can actually break it down and whatnot.
And we're going to do a whole episode about bacteria as well, because these are all just parts and pieces.
And I'll take one little second and say, if you guys do have any ideas or questions or things like that, there's a lot of rabbit holes, a lot of directions you can take these episodes. If you guys are interested in some specific, shoot us a comment. You never know. We might take that and run with it. In fact, even, some of this stuff came out of some of the questions that we've been getting. So anyhow, let's jump right back into it. Again, enzymes are proteins that help speed up metabolism or the chemical reactions. They build some substances and break others down. I think that's really important to note. All living things have enzymes. Another thing that's very important to note. Furthermore, there are various complex proteins produced by living cells that bring about or speed up reactions without being permanently altered. Another thing that's really important, and we'll talk about that and about saturation and things like that a little bit later, as far as it's really important to understand that can be used over and over and over and over and over again without being altered unless it's denatured. But let me not get too far ahead of ourselves. More specifically, enzymes act upon substrate molecules and decrease the activation energy. And that's a really important part of that. Decrease the activation energy necessary for a chemical reaction to occur by stabilizing the transition state.
So explain that to our listeners, what that helps do.
Well, long story short, it means that the plant has to put less energy into getting a chemical reaction done. So, and I know many times I somewhat misspoken and said that an enzyme doesn't need to be there. And in truth, it doesn't. But for it to do what it's supposed to do in the course of life, it needs to be there. And we'll get into that.
So really what we're doing is maximizing efficiency.
Absolutely. Which, although funny enough with Rubisco, it's not efficient, but I don't want to do it anyway. Almost all metabolic processes. Don't get too far there, Fred. Almost all metabolic processes in the cell need enzyme catalysis in order to occur at rates fast enough to sustain life. So maybe the chemical reaction would happen without it, but it's not going to happen fast enough to sustain life, and that's really important.
Well, and the thing, and we'll get into this with I think some of Jeff's stuff, is it's exponential.
Yeah,
so as you can have millions of them in a very short amount of time.
Exactly, and in fact, metabolic pathways depend on enzymes to catalyze individual steps. The study of enzymes, just in case anybody was wondering,
I love this
enzymology. So it's funny because that one's obvious, but some of them aren't. So anyway.
Hey, Latin for you.
Yeah, right. Enzymes are known to catalyze more than 5,000 biochemical reaction types. So I thought that was super, super interesting. Without further ado, let's go and see what our buddy Jeff Lowenfels has to say about enzymes and that's teaming with nutrients, correct?
Yeah, this is teaming with nutrients. It really had the best. I looked in teaming with microbes. There was definitely some good stuff in there. But this one, Jeff pretty much goes right to it. Enzymes are catalysts. Catalysts are substances that increase or decrease the rate of chemical reaction. Enzymes are protein that act as catalysts. They work in several ways. First, enzymes can form a template that holds two or more molecule substrate just in positions they bind or unbind. I thought that was really interesting. Second, an enzyme can get in between atoms of a molecule or molecules and force them into shape that results in bonding or other reactions. So again, this stuff is really critical.
It's actually forcing it into shape.
Yeah, it's moving the puzzle pieces. And finally, enzymes can change electrical charges on substrates by taking away electrons, oxidation, or adding them in reduction.
So redox reactions. Yeah, really important redox reactions. For anybody that's taken organic chemistry, boy, that's a bear, but anyway.
Yeah, no. The increased speed afforded by the presence of enzymes is nothing short of phenomenal. Reactions occur millions of times faster, which means nothing is left to chance. It's a good thing that these speeds can be achieved in biological systems. Cellular synthesis, decomposition, and a host of other critical activities such as respiration and photosynthesis would simply be slow to sustain life if it were not for enzymes. I gotta admit, I'm using more enzymes this round in the garden. So
sure.
I shouldn't say I'm trialing. I'm using the Scietetics 3-part powder, where you make a concentrate with, this is our commercial formula. And I am using a couple different enzymes. I'm using the Rhizium.
Yep.
I'm using the Slicium bloom.
Yep.
And, I can't, if I water the plants when the lights first come on, I'm in 7-gallon pots. I can't make it through I gotta either water them at midnight, and usually I'm kind of pulse feeding from when they come on. But if I leave them, when I come down in the morning, they're dry. And I'm going to admit right now, we're 2 weeks in and And they're already dry. Even if I water them at midnight, I'm coming down and they're dry. So, I mean,
well, and we can talk that a little bit more when we get into, because we like to start wide and then take it down to the product. So let's not ruin all the goodies in the future here, Gabe. Anyway, let's get back on track. Yes, I hear you though.
Well, we will talk about that was just an observation I'm thinking about. And honestly, they're drinking more than I've ever seen them drink.
Well, it makes sense. If you've got more roots, you have more surface area, then you got more uptake. But yeah, anyhow. Okay, so enzymes, like all catalysts, increase the reaction rate by lowering its activation energy, like we said. Some enzymes can make their conversion of substrate to product occur many millions of times faster. Yes, I said that right. Many millions of times faster than it would happen if it wasn't there. So an extreme example of this, and I'm probably going to screw up the actual pronunciation.
We never get it right.
Orotidine 5-phosphate decarboxylase. Actually, I did pretty good. Which allows a reaction that would otherwise take millions of years to happen. You heard that right. It would take millions of years for that chemical reaction to happen. Happens instead in milliseconds.
That's
that blew me away, dude.
But we don't need enzyme.
Yeah. By the way, we don't need enzyme. I mean, does that not?
I always say, like, in cannabis growing, you go from stoner to quantum mechanics in like 4 moves. It's so ridiculous.
I like that. So, I mean, you're literally looking at this and I'm just going, holy crap. So anyway, we do have fun putting these episodes together because, again, I about fell out of my chair when I read that yesterday. Chemically, enzymes are like any catalyst and are not consumed in chemical reactions. Very important. Nor do they alter the equilibrium of the reaction. So we know that a chemical reaction is equal on both sides, right? So it's not adding to that or taking away from that. Doesn't mess with the equilibrium. Again, very important. Enzymes differ from most other catalysts by having much more specificity, and that is based on shape that we'll talk about here shortly. An enzyme's activity decreases markedly outside its optimal temperature and pH. Something to also really note. Why is standard
very,
pH
very important?
Super important. And many enzymes are permanently denatured. That means they lose their shape when exposed to excessive heat, losing their structure and thereby its catalytic properties.
Well, and that makes a lot of sense because obviously the lower the pH, more acidic, acid kills things.
Acid. You don't say.
You don't say, do you? Let's keep it simple there, Charlie.
An enzyme's name is often derived from its substrate or the chemical reaction it catalyzes, which we were talking about before. And so it basically with the word then ending in ASE. Examples are cellulase, which catalyzes cellulose. Right?
Yep.
Pectinase, which catalyzes pectin, and beta-glucanase, which catalyzes beta-glucan. And that's a little bit of a...
Jeff talks about the same thing, basically.
So, and a little teaser there, all of these can actually be found in Green Sensation.
See, I left one for you. See?
Okay. Why don't you talk a little bit about the structure, Gabe? We kind of go...
Mind sliding that up a little bit for me, Graham Beasy?
There we go. Perfect.
Structure, a large protein enzyme molecule is composed of one or more amino acid chains called polypeptide chains. The amino acid sequence determines the characteristic folding patterns and the protein structure. So again, as we were saying, very important is the structure, which is essential to enzyme specificity. Again, we've discussed all these thousands of different enzymes. They all have very specific jobs that they do. If the enzyme is subjected to changes, such as fluctuations in temperature or pH, the protein structure may lose its integrity, denature, and its enzymatic ability, which means basically it's not going to be as effective, So
or even won't fit in at all. It just is completely it's rendered obsolete at that point.
Yep.
Now, denaturation sometimes, but really, from what I understand, not often is reversible.
I will,
and I don't know how necessarily. I don't know who goes and fixes said protein, what organelle that it ends up in or whatever. But anyway.
I mean, here's and not to. Because I know we're going to talk about it later, but maybe that's one of the magics in the Rhizium. Because I know when we were doing the trials, we had clones, and we were doing this on purpose. Sure. We had clones that were like, these things were terrible. I mean, the roots on them were brown and slimy,
which are the best things to trial.
And we hit it with the Rhizium, and you saw at the end of this, you saw beautiful bright white roots coming out of this. I'll tell you what. When it started with New Millennium for me in 2017, it was always seeing as believing.
Right.
That stuff was seeing as believing. I mean, it was, I always tell people you could grow roots on a popsicle stick. That's why.
It's true. And speaking of that, and we'll talk about this again in a later episode, but while, we have most of our listeners still with us, The Rhizium will be on the website by the time this airs. And also, we do have it available in 125 mil size for sample as well.
Dude, 1 mil a gallon, 125 mils goes a long way.
Goes a long way. Okay, so
take us away.
Let's talk a little bit about, get back to the activation energy aspect of that, because to me, like that is one of the things that I've always used in, one of the big technology aspects of green sensation, which we'll talk about, is really, again, more efficiently being able to produce your own hormones, your own oxygens, things like that, which we'll talk specifically about. But in most chemical reactions, an energy barrier actually exists that must be overcome for the reaction to occur. Again, that's where enzymes come in. This barrier prevents complex molecules such as proteins and nucleic acids from spontaneously degrading, and so is necessary for the preservation of life. Pretty important, it sounds like. When metabolic changes are required in a cell, however, certain of these complex molecules must be broken down, and this energy barrier must be surmounted. Heat, because heat is energy, could, in theory, provide the additional needed energy called the activation energy. However, the rise in temperature would kill the cell. So, again, all these things, and I really enjoy putting this out there, and I've read through this many times, and it still kind of blows me away every time, really.
One thing... It's interesting because water temperature when you do water is so important.
Yeah.
And if you skirt that 72 degrees plus,
right,
you're really in a zone where,
well, and again,
things get bad.
But doesn't all of it make sense now?
Yeah.
The pH ranges, the temperature ranges. Shoot. Okay. And even in theory, heat could come in and boost that up and get over the energy barrier, but now the cell's dead.
Well, and that's why
right?
That's why we tell people, when I had the 1,000-gallon tanks and I had Monty pumps in there, put that thing on a timer.
Sure.
Don't let it run all the time because the heat from the pump is going to heat the water.
And
if you have stuff like carbonaria, anything like that in there, all of a sudden, you come in and you smell it, and that's how you know.
So, and also the nose knows. What is the alternative then? Well, I have an answer to that, believe it or not. The alternative is to lower the active energy level through the use of a catalyst, i.e., an enzyme. Yep. This is a role that enzymes play. They react with the substrate to form an intermediate complex, a transition state. So you have the substrate, you have the transition state, and then you have the product, right? That requires less energy for the reaction to proceed. The unstable intermediate compound quickly breaks down to form reaction products, and the unchanged enzyme is free to react with other substrate molecules. Again, that's a super important fact. Just the fact is like, okay, got through that reaction. Next. Can you move that up a little bit, please, there, Grambo? Only a certain region of the enzyme called the activation site binds to the substrate. The activation site, I can't see. The activation site is a groove or pocket formed by the folding pattern of a protein. This three-dimensional structure, together with the chemical and electrical properties of the amino acids, which are important, right? You have, some polarity and things going on there, and cofactors with the active site permits only a particular substrate to bind to the site, thus determining the enzyme specificity. This is called their tertiary structure and is very important. And if you could pull that up, that image that we have to give a little bit.
See, it's funny too, because when we were discussing the Golgi apparatus before this, literally that is a folded pocket that holds enzymes. You know what I mean?
Yeah.
We know it as a silly fish song. But
Indeed,
it actually is a real thing.
Yeah, it is a very real thing. And again, enzymes are part of every single cell, every single part of life, animal cells, plant cells, and everything in between. So this was one of the better picks I was able to find just to show, that specificity and that, it has to be folded and fit in, and kind of a lock and key is one of the models that they have that they talk about. There's a couple different models. And again, keep in mind, people, we know a little bit about plants. Not a lot. And I'm not saying me and Gabe. I'm saying society. I'm saying humans.
Yeah.
Only know a little bit about plants. So like a lot of this stuff, we know that the enzyme's there. We may not know exactly how it fits together, but we know the specificity. We know it's wild how much we don't know about plants. We know where things start. We know how things end. A lot of times we don't really have a lot of idea what's going on in the middle. And part of that's because just even like in that one, what would take millions of years takes milliseconds. How the hell do I even know how do you even test that? How do you see what all these different variations as it's jumping through the transition state? Wild stuff.
And I think for us, we want people to understand that it's way more than just the 17 essential elements like we always do.
Well, yeah, again, but enzymes are part of those biostimulants.
So much more. Bacteria, enzymes.
Yes.
pH.
And again, I do think we're going to just bust down a whole bacteria one as well and talk about anaerobic and aerobic and everything. That's a little teaser for the next one. Okay. Because enzymes are not consumed in the reactions they catalyze and can be used over and over again, only a very small quantity of an enzyme is needed to catalyze a reaction. Also a great point. You don't need to have a ton of it, right? A typical enzyme molecule can convert 1,000 substrate molecules per second. Not bad. Seems like a pretty good rate.
I mean, we feel, it's funny because these are products of nature that are computing just as fast as any supercomputer.
Wow. Well said, my friend. Well said. Well said. And in fact, the rate of an enzyme reaction increases with increased substrate concentration, reaching maximum velocity when all active sites of the enzyme molecules are engaged, but not until then. But that's so it's always, give me more, feed me until saturation.
Well, and that's why I always say, we talk about IPM, but some of your best IPM is having healthy plants. Yeah. I climb a lot of mountains. I do a lot of stuff. And there's one thing I definitely say is like the best way to be ready is to stay ready. You know what I mean? Get ready. So you don't get ready, you stay ready.
And that's why you keep your plants, you keep your plants ready at all times. Why don't you talk a little bit about the history? I don't have a lot because I'll be honest, it just got a little bit thick. But I wanted to give a little bit of history on the word enzyme. Obviously everything comes from some Latin base typically. But run with it there, Gabe.
Well, and we're basically, if you've followed us enough, we've discussed elements and all this to know that the early 1800s, there was a lot of shit going on.
A lot of stuff going on.
A lot of people. So French chemist.
And as you'll notice, I gave Gabe all the really hard names.
Hey, man. French chemist Anselme Payen. That sounds like there's like a joke in there. There's a joke in there. But either way, he was the first to discover enzyme diastase in 1833. A few decades later, when studying the fermentation of sugar to alcohol by yeast, Louis Pasteur,
which is a very familiar name, the
father of pasteurization, obviously, concluded that this fermentation was caused by vital force contained within the yeast cells called ferments, which were thought to function only within living organisms. He wrote that alcoholic fermentation is an act correlated with the life and organization of yeast cells, not with the death of the cells, which I think was...
And that's why I put that in there, because I thought that was just kind of an important piece, that they weren't onto it completely yet, but he realized this is a living thing. This isn't about a dead thing.
Yeah, there was a lot... We were coming out of the dark ages,
bro.
So there's a lot of discovery going on. So in 1877, German physiologist Wilhelm Kuhn first used the term enzyme, which comes from the ancient Greek leaven in yeast, to describe this process. The word enzyme was later used to refer non-living substances such as pepsin, and the word ferment was used to refer to chemical activity produced by living organisms.
So obviously, as science happens, we start, being a little more specific with our with our wording and with our nomenclature. That was the word I was looking for.
I think, before that, they just tossed a bunch of stuff in a barrel and
see what the hell happens.
They were like, hey, we don't know what happened, but it gets us wasted.
We're not sure. Wanted to go through some quick examples of it, right? And talk about, and these aren't, from here, we're going to move into enzymes and plants specifically. So there will be a little bit of plants and animals here, but practically all the numerous and complex biochemical reactions that take place in animals, plants, and microorganisms are regulated by enzymes. And so there are obviously a variety of examples. Among some of the better known examples are the digestive enzymes of animals. The enzymes pepsin, for example, is a critical component of gastric juices, helping break down food particles in the stomach. Again, like we said, it can build up or break down things. Likewise, the enzyme amylase, which is present in saliva, converts starch into sugar, helping to initiate digestion. In medicine, go ahead.
That's why they tell you not to eat your food too fast.
Don't eat your too food. You got to get it saliva up
in there.
In medicine, the enzyme thrombin is used to promote wound healing. Other enzymes are used, again, that's a buildup. Other enzymes are used to diagnose certain diseases. The enzyme, which I thought was interesting, lysozyme, which destroys cell walls, is used to kill bacteria. Have you ever heard of Lysol?
Hey,
I love when things start making sense like that. It's like,
Grambo, is thrombing going to get us age restricted?
I'm thrombing right now.
I'm so throbbing.
There you go.
On this information. The enzyme catalase brings about the reaction by which hydrogen peroxide, which we were talking about earlier, is decomposed to water and oxygen. Catalase protects cellular organelles and tissues from damage by peroxide. So it's coming in and breaking them apart so it doesn't damage. I thought that was really cool.
Yeah, I was going to say, and that's definitely something we want people to take away from this is that, you know, different enzymes have different jobs. Some things help, or some things are there to bind things together. Yep. Some are split apart. Yep. Some are there to protect. Some are, you know, there's lots of different.
Man, here's the thing, man. Well, proteins in general, right? So amino acids that are then the building blocks of proteins, which enzymes are proteins, which turns out it actually gets a lot more complicated than that. Just saying that all enzymes are proteins, as it turns out, is not exactly 100% true.
It's not a blanket.
And again, that's a rabbit hole. You guys can go down yourself. Anyway, let's talk more specifically now about enzymes in plants, because that's what we're all here to talk about is plants. Okay, so in plants, enzymes are present, again, in all the living plant cells of the plant body, just like we had said. Plants are multicellular organisms, mostly photosynthetic, because can't say all, eukaryotes in the kingdom Plantae. Green plants obtain much of their energy from sunlight by photosynthesis through primary chloroplasts. Again, we're just doing a little bit of a quick review here.
You guys have heard this from us before. This is not new.
This is right. Chlorophyll A and B are present in their chloroplasts, which give them their green color, of course. Building blocks are proteins, carbohydrates, fats, and fibers, but they do not have the energy required for biochemical reactions. So this is where our friend, the enzyme, comes in. Enzymes are catalysts that can supply energy. They are protein substances capable of catalyzing biological systems' chemical reactions without undergoing any modifications on their own. In all living cells, they are made. No life cycle can successfully be carried out in the absence of enzymes. So there are 4 very specific types of plant enzymes.
Say, literally, that's the same. You know, it says enzymes are extremely crucial to all cellular activities, but they metabolic or synthetic. There is no life without them.
None.
It should not come as a surprise that once an important enzyme cannot be replicated, a cell will die. Remember, life in a cell, life in general, actually, is only a series of chemical reactions. If you don't have enzymes to speed these up, you don't have
everything
life.
That's going on right now is chemical reaction. There's no life. And again, I know that I misspoke for a long time saying that the enzyme doesn't need to be there. Well, okay, it doesn't if you don't want to have life. So, right? So, like, I wasn't totally wrong.
Not trying to be a dick here, but
I mean, I'm just saying. So anyway,
we can argue about it. The thing is, you'd be wrong. Well, it's okay.
It can happen. It might take millions of years in the case of the one,
or just seconds with the enzyme.
Yes. Again, I mean,
milliseconds, not even seconds.
Yeah, not even seconds.
And then we want you. Regardless of regardless of what you were growing, if it's cannabis, if it's vegetables, if it's houseplants, we talk about the secret life of plants. And we want you to have that connection with your plants where you are growing your plant. It's the best you can.
Yep.
Literally, they are happy to see you. They know. They are happy to see you. I promise.
Might be sentient beings.
I promise. They're happy to see you. But the more you give them of this stuff, the happier they'll be.
So why don't you walk us through the four plant enzymes, right? And again, they're all going to end with ASE, right?
ASE, yep.
And that's what signals that it is in fact an enzyme.
So we have the protease? Protease. They break down long protein chains into smaller chains.
Protein.
Of chains into smaller chains of amino acids and ultimately into single amino acids. Again, that's.
And then we're now getting
we talk about sizes and small, we have the amylases, which reduce the disaccharides, polysaccharides, lactose, maltose, and sucrose.
Sugars.
Basically your sugars. You have the lipases, which they break down the triglycerides, the glycerol, and the individual fatty acids. That's why you see lipids, and then the cellulases, they digest complex bonds of carbohydrates found in fiber.
And also things like plant cell walls and stuff like that, which is one of the reasons that you will see, in a number of products we've classically seen in our industry, you'll see obviously cellulase, because you want to be breaking down dead plant cells and getting rid of them and yada, yada. So we will talk a little bit about, and I'll mention it when we get to the end, just about a specific enzyme product versus having an enzyme as part of a product, but we'll get into that. So what are the roles of enzymes in plant metabolism? Plant enzymes are, again, as we said, indispensable for plant metabolism and are critical determinants of the extensive chemodiversity observed in plants. These enzymes serve as primary catalysts in biosynthetic pathways, enabling the biosynthesis of a diverse range of secondary metabolites. Listen very closely here, folks, such as alkaloids, terpenes.
What?
Oh, we are getting somewhere. And phenolics. These metabolites are essential for the distinctive sensory qualities of plants. In other words, the flavors, the scents, and the colors. Okay. So enzymes, again, I knew about enzymes, but I didn't know all this. Okay. So what is the most abundant enzyme in plants? I'm going to screw this up again, but ribulose 1,5 biphosphate carboxylase oxygenase. Actually didn't do too bad. Better known as the name Rubisco. From now on, it's just Rubisco, folks. I'm only doing
Rubisco. Ding.
I'm not doing it. I am only doing it once.
I couldn't help myself.
That was solid. Okay, so Rubisco is the key enzyme responsible for photosynthetic and chemoautotrophic carbon fixation and oxygen metabolism. Scientists believe it is the most abundant enzyme on the planet. Rubisco. So that's something that I had not, I had heard about it before, but wasn't something that necessarily had come across my plate a ton. But I did have some fun starting to scratch the surface of it because Rubisco, it turns out, has been providing the energy which fuels life on our planet for the last 3 billion years. So it kind of became interesting to me.
Yeah, no, it's funny because you sent me down a little bit of a rabbit hole last night. And, this is when we... Just talking about cellulose, cellulose, a complex carbohydrate made up of long chains of carbon-based glucose, is a molecular material that gives the plant structure. As we see, it constitutes half the mass of the plant's body, and hence half the mass of organic matter created by the plants. This is what I was talking about when we're going to go into bacteria, because this is something I found really interesting. Specialized bacteria like the aptly named Cellulomonas carry cellulose breaking enzymes that they only release when they come into contact with cellulose, as opposed to the random release enzymes by other bacteria who eat in a hit and miss manner. So again, we were talking about that specialization, and how there's 5,000 different,
that we know of, by the way,
that we know of. And that's one of the things I found really interesting is the fact that you have these ones that have very, very specific jobs. They interact, and they need bacteria to work. So that's for us, that's really, we can't have a 5-hour episode.
Well, that's, and literally you'll see the last. Well, I'll get to the last note that I have on this very quickly. But the crazy thing is, Rubisco is literally fixing billions of tons of CO2 each year. The enzyme, but we talk this whole time about how enzymes make things more efficient and everything else. Here's where I'm gonna throw you off a little bit.
It's not the most efficient.
Here's where I'm gonna throw you off a little bit.
Yeah.
Okay. It is notoriously inefficient. In fact, this has created a biological paradox that has puzzled researchers for decades. Rubisco seems to have adapted only partly to the new world it helped create. A large portion of its reactions swap oxygen for carbon dioxide. So instead of creating 2 3-carbon molecules, it creates 1 3-carbon molecule and 1 2-carbon molecule. So this yields no gain in carbons and results in a loss in energy. What the, you know what I mean?
Dinosaur enzyme.
Yeah. So, anyway, I find this stuff incredibly interesting. I hope you guys do too. There's a ton of fun rabbit holes you can now dive down based on some of the stuff we've gone over there. From here, we're going to move it a little bit more into the products that we have that are going to help with either create enzymatic activity. In fact, this is what I'll talk about right away. And let's chat about this a little bit, Gabe. Why doesn't New Millennium or any of our things have a single bottle with enzymes in it? Well, I'm going to tell you why. In part because enzymes are created by a lot of these associations. A plant is continually creating enzymes. Cells are continually creating enzymes.
Bacteria.
There's all these things. It's all these associations and all these ratios and everything else. So you want to create and open up metabolic pathways, like we'll talk with Rhizium, to do it itself and make it more efficient. But the reality is enzymes happen. Bacteria happens. Life happens. So that's the one reason. So I, almost heading off a question of like, why don't you guys have an enzyme specific bottle, which some people do, and I'm not knocking them for it.
Look at the carbo though. Carbo is a perfect example. It's the sugars that the enzymes, that those specific enzymes we just talked about
want to associate with and break down and make available and everything else. Yeah.
We're going to make, feed your enzymes and you're going to and you feed your enzymes with really quality material, you're going to have happy enzymes.
Well, and I think,
plants.
you know, at the end of the day, you know, I think the one thing you can walk away from here is just truly having a higher appreciation of what enzymes mean to life
and biodiversity. I mean, you know, again, and I still got to look it up, but you know, we were having that because this got us going down the rabbit hole before the show of does hypochlorous kill enzymes, you know, in which then all of a sudden, you know, that explains.
And I mean, in my opinion, you know, it's obviously going to denature them. But while you're looking that up, let's just talk a little bit. Yeah. So obviously we like to move this into, we've talked about enzymes, everything else. So what 5-8 products do we have that actually apply to this? Well, we've been talking a lot more about Rhizium. We also talked about it early on. If you can pull up a pic again of it here in a second there, Grambo, but Rhizium, right? So think about Rhizosphere, right? When you're thinking Rhizium, the newest member of the Slicium line of products introduces a new technology specifically tailored to the Rhizosphere for any phase of the plant cycle. The technology within Rhizium is specifically designed to stimulate system development in terms of follicle hairs and the rhizosheath, which is the substrate particles directly adhering to root surfaces.
Okay, so quick, easy answer. Yes. Hypochlorous acid can inactivate enzymes.
Of course.
I think, you know,
of course.
You would figure it makes sense.
It makes sense.
You know, but I just want to make, you know, before I just go yammering on and with the wrong answer.
Totally. So this is where Rhizium becomes important when it comes to enzymes. A combination of proprietary acids open up metabolic pathways, within the plant that encourage protein and hormone synthesis. We obviously know enzymes are a protein. We know they're continually being manufactured. So what we're doing with a product like this is not only creating root hairs, we're also opening up a bunch of metabolic pathways, you know, i.e. some of the proprietary acids that we have in there. The direct result is obviously hyperaccelerated production of root biomass and reduction of root disease pathogens. You know,
that is for real. That is for real.
Well, what do you like to say that it does?
It'll grow roots on a popsicle stick. That's the truth, dude. You dip your finger in that stuff, you grow roots in your finger.
So Rhizium is one. If you can move up a little bit, Green Sensation is really the other one, right? And so if you can pull up a pic of that as well. Green Sensation is from Playground. That's a product that we actually import out of Holland.
If you know us, that's been for years.
Yes, we like 5-8.
I often say it's my secret weapon. Like when people ask, like, "Oh, how do your plants come out so good?" It's like, dude, I get that Green Sensation and use it liberally.
Yeah, so you guys that know the secret sauce recipe and everybody that wants it, feel free to reach out. I'd be happy to send it to you. But it's a full New Millennium line with Green Sensation and Slicium stacked on top of it. So Green Sensation is, as we know, is way more than just a booster. Green Sensation produces the best taste and yield in every growing situation, indoors and outdoors. It can be used with every substrate, growth style, and irrigation system. It has a long shelf life and it's easy to mix. You don't need to buy a separate PK fertilizer, enzymes, enhancers, or boosters because it's really a 4-in-1 bottle. 4-in-1, right? Yep. What is it? PK fertilizer, it's enzymes, it's an enhancer. How's it an enhancer? It makes sure that the sap flow actually is maximized and contains the nutrients needed to activate the processes that ultimately result in the best taste and yield. And then last but certainly not least, it's a booster, but it's not necessarily a booster in the way that you think it is, right? So as we mentioned before, it is enzymes. It's pectinase, beta glucanase, and cellulase that helps fully break down what's actually a double cell wall in plants. So right, you have that jelly in between it, which is the pectin, then you've got the cellulase and beta glucanase on the double cell wall. That's why you need the 3 as opposed to just 1. But if it's just 089, which is a little bit of PK. It does actually have an iron supplement, which iron's an essential part of chlorophyll production, so keeps everything nice, green, and raging. We've got some basic enzymes in there, which are good to have. We obviously know, we can see that. I think we all believe in that at this point. We know it's enhancer by maximizing sap movement, but what really justifies the fact that it's rather expensive, right? Well, it's the booster aspect of it. It's a 4-in-1 and the booster. So really, there's a number of secret nutrients that are responsible for this. But what makes Green Sensation truly special, it has an additional enzyme that, and all this is coming together, guys. It has an additional enzyme that actually lowers the activation energy that a plant needs to create its own indole-3 acetic acid.
You mean an enzyme?
I do mean an enzyme. And what it does is, auxins, indole-3 acetic acid, it's creating its own hormones, but it's doing it much faster with that particular enzyme present. And what are we doing? We are saturating that enzyme so that process is maximized. That's where the technology is, and that's really how it's a booster. It's a 4-in-1, and it has a proprietary and incredibly special, I'll be honest, I don't even know what that enzyme is. But it's so guarded information.
It's so funny because now that I think about, indole butyric acid and all the rest of these different acids, it all makes so much more sense.
Isn't it fun when that happens? So those are the main things we actually have as far as what's going on with the products that we have and with enzymes and everything else. We don't really have any current events to talk about in cannabis today. I didn't have anything that's really popping across my screen.
I mean, look, there's, if you're in South Dakota, get out and vote. If you're in Florida, get out and vote.
Yeah, there's definitely votes going on.
There's some votes going on.
And by the way, I'm not even going to say one way or the other because I know that there's a lot of back and forth in Florida because I don't think there's a personal grow element into it. No. There's a hell of a lot of corporate money that's coming.
I know True Leaf.
Well, I wasn't going to name names.
I know True Leaf don't.
Wait, it's all money. Yeah, well, it's all.
Go ask Ron DeSantis. Truly, he's not afraid to tell you exactly who
I stayed at a hotel this last weekend. South Park's episode was about Randy and Tegrity becoming big cannabis.
Right.
And he suicide bombs every home grow in Colorado.
Oh, God.
So I was like, oh,
yeah, wow, that's strangely, it might be accurate.
Yes.
Let's talk real quick about where we're going to be at, coming out and about. Gabe, I know that you are going to be at the Cultivate event October
5th.
October 5th.
I'll be there too.
5th. That's going to be, I think that's from 2 to 5. It's going to be the showdown.
It's another showdown. So they've always done a really good job with that. Shout out to Cultivate.
Basically a run what you brung situation. If you do have some flower that's grown with some New Millennium, we'd
bring it on down, put it in there.
I'll tell you what, last time, win, even if you don't think you win, it's
last time was some very, very, very good samples. All three of us were there, and I was quite impressed.
Yeah, there was some fun.
We'll also both be at October 24th. We will be at, shout out to Michigan Matt. We'll be at Matt's event in Hazel Park.
We'll shout it
but
out
it's basically, I mean, it's more of a commercial grower gala type thing. He is, if you get on Michigan Matt, he's hitting it up on his page. It is an invite only event, but I know he did one before and it went really, really well. So we're super excited to be out for that. You will see us. And then Gabe will also be running around that week in Michigan too.
Yeah, I'll be checking out a couple grows.
If you guys have any grows or have any stores you want to stop by, let us know. Gabe will be running around. And one little shout out I want to get is to my co-host here. He actually did, we usually like to keep some lifestyle stuff in here, but just a little bit of shout out. He did Grays and Tories, did a double 14er in one day. And I know that's quite a feat. So good job, Gabe.
Dude,
and
thank you very much, man. That was, it was a fun adventure. I'll be honest with you. I think it was one of the easier ones I've done. I don't know if it's just because of the shape I'm in right now,
sure.
But the shout out to the Colorado 14ers initiative, the crew that was doing the trail maintenance.
You said that. In fact, G Money Love, you can get up, you can see some pics of it. Get on his IG.
I am wearing.
There is.
It's funny.
Rambo's ahead of me.
It's
God
funny,
dang it.
dude. It's funny with this because I am wearing the New Millennium hat there. And the thought that went into it that morning was it's vented it's the baseball style that's vented on the backside. So I was like, dude, my head will be able to breathe.
Yeah.
I'll still get protection for my eyes and stuff. So it was a really fun experience. It's one that's been on my list for a while. I think I'm up to
Congrats.
I'm up to the top of 10 now. So double digits. I'm pretty excited, but thank you very much, man. I appreciate it.
No, that's awesome. I wanted to make mention of that.
Thank you. And for any of our listeners, man, we encourage you guys to
get
outside, be active, enjoy wherever you are. Download the All Trails app because I'm sure there's some cool trails no matter where you live.
So real quick, going to do some supporter shout outs. We already did Michigan Matt. Hit him up on IG. We also have Indoor Dankster 28.
Yeah, shout out to him. He is a super supporter.
Yes, absolutely. And he's got that the Black Forest breath that he tagged us on, looking absolutely fire. Also Cosmic Gardener 1, your GMO punch, looking great as well. And I did want to say this. Anybody out there, shoot us a tag us and you might get a mention. That's what,
More people need to tag us in your, if you grow with New Millennium, tag Jug Dealers.
Scietetics, any of it.
Yeah,
any of it.
It all ends up in our stories.
I don't care if you use Slicium and someone else's product. Tag us, tag the product.
Tag us up. Shop shout outs, Grow Time Garden Supply, Aaron down there in Jeff City, Missouri. Great crew down there. They've got all their products in stock, including Dutch Lighting Innovations, all New Millennium, Slicium, pesticides, all the good stuff. Desert Hydro in Palm Springs area. So that'd be the desert, I guess that's, far eastern LA County or maybe even San Bernardino County. But out there in the high desert, they are looking to get our products. They should have some in stock.
That may be my favorite airport in the entire country.
I do like that.
It is. You walk off the plane, you're outside.
You're
it's
outside.
Awesome.
It's wild.
You guys travel so much, you could have a podcast about like hotels, airports.
I'll be honest with you. I travel a lot. I camp a lot. You know,
you both also can't. You guys are active. Yeah.
We try to be, you know.
So they're not just shaking their finger saying be active.
No, we
get out. We get about. And in fact, Gabe's going to be doing the Grand Canyon here. He's going to do rim to rim. I'd love to do it with him. I don't think I'm going to have the time. And I was actually supposed to go down and do the Havasu hikes.
Come on. We'll go hit some stores. Come on.
It got postponed till April because they had a big flash flood. So anyway.
And at this point, I might be soloing it.
So yeah, that's true.
And last but not least, hit
him up.
We got Nature's Isle. Hydro
Island,
in Nature's Isle.
Nature's Isle, sorry.
In Maryland. These guys are a pretty new shop, but we've had some people going in there and talking to them. Go in, tell them you want our stuff. We'll get them to get it in there. If you guys have any harvest snug shots, like we said, go ahead and send them in. We'd love
tag us up. You might get a mention. You know what I mean?
We'd love to shout you guys out. As always, we love you guys.
Thank you for listening, guys. Had a fun one today.
Thank you for listening. Go read up on some enzymes, and we'll see you soon. Peace and love.
Thanks, guys. Peace.